All right, so now we're looking at some categorical data stuff. So calculate some percentages. So identify the variables and tell whether each quantitative or categorical. So our variables are going to be on the sides here. So it looks like we're interested in their sex and their transportation. So their mode of transportation. Both of those are going to be categorical. The sex categorical is just male or female. So obviously clearly sorted into two buckets instead of a scale or a continuum with units. It'd be kind of funny if we had units of male or femaleness, but we don't. Transportation categorical, so there's just three categories: bus, ride, and personal. So those are both clearly categorical. What percent of students are girls who ride the bus? So of all the students, which is of the 188, what percent are female who ride the bus? That's 34 out of 188, which when we put in the calculator, we'll get that. What percent of the girls? So now we're thinking of only the girls. So female girls, the marginal distribution is 102. So of the 102, what percent of those ride the bus? So 34 out of 102, which would give us 33.3 repeating. So a third. What percent of bus riders are girls? So of the bus riders, the 64, what percent of those are girls? 34 out of 64, which is 53.1. What's the marginal distribution of gender? So we're looking at only gender here, so we're collapsing. We don't care about bus, ride, or personal. We're just collapsing that variable to look at the marginal distribution of only gender. So we have 86 out of 188, which is male. So 45, again. So 45, now I'm just tired, 45.7 male, and for female, it's going to be 54.3. All right, write a sentence about the conditional relative frequency distribution of modes of transportation for the boys. So now we're going to break it down to a conditional relative frequency for only the boys. So we're only looking at the boys here, and we want to look at the distribution of their modes of transportation. So we're going to do 30 out of 86, which will give us the percent for the bus, 37 out of 86, which will give us a percentage for riding, and then personal is 19 out of 86, and that'll give us the distribution for the percent that were personal. Altogether, those should all add to 100, and they do. And this is our conditional distribution for boys, their distribution of mode for the boys. Mode of transportation. All right, do you think transportation is independent of gender? Well, we've already calculated a conditional distribution, so if we compare that to a marginal distribution, then we can see if they're the same. So let's go ahead and do the marginal distribution. So we'll do 64 out of 188. So for the total, and that's done here for you. Then compare these two numbers. If they're independent, they'll be the same. If they're or really, really close, about as close as they can get. But if there's evidence, if they're different, then there's evidence of an association. So of the boys, about 34.9% rode the bus, where 34% altogether rode the bus for our marginal. So that's really close. The riders are same or really close, and same with personal. So it does not look like your probability of taking the bus or any different mode of transportation is affected by sex. So being male does not increase or decrease your chances of choosing one mode of transportation over the other. Students' biology class kept a record of heights and centimeters of plants for a class experiment. So we want to graph the histogram. So to do that, we're going to put in our data into our calculator. I put it all into list 5. So there's 20 of them all together. Then we want to graph it out. So I'm going to do second stat plot, turn on just one plot here, go to a histogram, and then put in your list. Mine's list 5. To graph it out, if we just click graph, well, that worked because I had done it before. But anyway, to get it to that, because yours probably won't show it, we have to hit zoom and 9, which is zoom stat. But the problem here is that our window is not going to match up. If I hit trace, this window is not going to match up with what I have graphed out for you, which should be what you're going to want to do. So we're going to change our window. Our minimum here is 30, maximum is 80. So we're going to go from 30 to 80 with the X scale. Looks like we're going by 5s. Bin width of 5. So then hit graph, and we're going to graph that out. You can hit the trace button to actually see what those numbers are. So it looks like our mode is from 45 to 50, and it's 4. So when we graph it out, we have something that looks along the lines of that. Okay, sketch a histogram, so do that. Find the mean and standard deviation. So for mean and standard deviation, we go to stat, arrow over to calculate, one variable stats, and then we're going to do second 5 for the list 5, if that's the list you put it in, and then hit calculate. The mean is going to be the x bar, which is 51. Standard deviation is the s of x, which is 10.6. To get the other 5-number summary, that's going to be the last 5 right here. If we compare our mean to our median, so 50.5 to 51, we'll notice that our median is slightly less than our mean, which tells us that our data tends to be slightly skewed towards the lower numbers. Or our mean, sorry, is skewed towards the higher numbers because our mean follows the trend. So in other words, this value here, which might be a potential outlier, without it, it looks really unimodal and symmetric, but this outlier might be moving that mean away from the median of 50.5 to a mean of 51. So if you notice the difference between those, the mean is 51 where the median is 50.5. So that tells us that it's slightly skewed to the right. Is it appropriate to use the mean and standard deviation to summarize the data? This one, honestly, you could probably go both ways. It's not egregious, and looking at the histogram here, it does look like it's slightly skewed to the right. So if you said no and you told me because it was skewed to the right, that's fine. You get full credit. If you told me that you believe that it was roughly unimodal and symmetric, there was a potential outlier, but you didn't think it would mess it up that bad, that's okay as long as you tell me your justification. So sometimes it can go both ways. Personally, I don't know. I don't know what I would do. I would probably go ahead and use mean and standard deviation, as long as I told you that I thought it was roughly unimodal and symmetric. All right, describe the distribution of the plant's height. So we're going to describe it as unimodal, symmetric, or roughly symmetric, or slightly skewed to the right. There's a potential outlier. For the highest plant of 75 is a potential outlier. If you want to know if it actually is considered an outlier, you can always graph a modified box plot above it. So I'm going to do that for list 5. And that'll actually it'll calculate the fences for you, which is nice. And oh, you actually have to turn the plot on. There we go. So it's not actually considered an outlier because otherwise it would have the dot there or whatever mark I chose. But you can see it's skewed to the right because the right whisker is longer than the left whisker as well. All right. A local plumber makes house calls. She charges $30 to come to the house, $40 per hour for her service. For example, 4 hour. So you have the base price plus the hourly charge. Table shows statistics for the month. Fill in the table to fill out the cost for the service. Okay. So what's going on here is this is the number of hours, which is going to be our variable that we plug in. Then it's going to be multiplied or scaled by 40. So for every hour, it's $40. Okay, and then it's shifted by the $30 base charge, which she charges everybody. All right, so the mean in this case is going to be multiplied by 4, and then it's going to be added 30 because whenever we have the only things that are not impacted by this 30 are going to be measurements of spread. So let me see if I can, measurements of spread, which the measurements of spread are going to be the standard deviation and the interquartile range. So those, the fact that we shifted it by 30 are not going to impact everything that we by the 30. So I could plug these in the calculator, it's just going to take me some time. All right, so the 4.5 is going to be multiplied by 40. And then we're going to add to it the 30. Okay, so that's going to be 100 or 210. I'll just let you fill them in. Same thing with the median because that's a measurement for an individual point. So 3.5 times 4, and then we're going to add 30 to it because it will be shifted. The standard deviation and IQ are only multiplied by 40, so that would be 48 and not 48, 4.8, and then multiply, I'll just put it in here, it's fine. So that times 4D, which is, 48, I don't know what I was thinking there. And then 2 times 40, which would be 80, no big deal. The last one we have is the measurement of the minimum, which is going to be shifted and scaled and shifted. So that would be 20 plus 30 more, which is 50. All right, local plumber makes house calls. She charges $30 to come out, $40 per hour for the service. We just did that. I must have updated it, but forgot to change it. All right, 22. On this one, they give us the summary statistics. They want us to see if there's any outliers, so calculate the left and the right fence. So we're going to do Q3 minus Q1, and then multiply that by 1.5. So our Q3, oh, that is a big window for the calculator. All right, so our Q3 is going to be 116.7 minus our Q1, which is 10.8, and then we multiply that times 1.5. Okay, so that's going to be 1.5 times the IQR. Then we're going to add that to our third quartile, and we're going to subtract it from our first quartile. So we have a left fence and a right fence shown. Our minimum is larger than our left fence, and our maximum is slightly bigger than our right fence. So that means that we would have an outlier because our maximum is greater than our right fence. So we have at least one outlier, and it would be our maximum. Now there could be another point that's in between our right fence and our maximum, but we know we have at least one outlier, and it would be with our maximum on the right side. Okay, so looking at the histogram here, is it appropriate to use mean and standard deviation or median IQR? So it does look like it's more or less unimodal here, but it is clearly skewed to the right. So we would not use mean and standard deviation. Instead, we would use median and IQR, because when we have data that is not unimodal and symmetric, we cannot use mean and standard deviation because a bell curve is not appropriate. Cost for a standard veterinary service at a local animal hospital follows a normal model with a mean of $80 and standard deviation of 20. So you can fill in the model down here. So we have 80, then we're adding, on this one we're adding $20 each time. So I can fix that. All right, so the question is it unusual to have a vet bill of 125? You could calculate the z-score if you want. So observation minus the mean, so 125 minus 100 is 25. 25 divided by 20 is going to be 1.25. So what that's saying is we have a standard deviation or a z-score of 1.25, which is not considered unusual. We don't consider an observation to be unusual until it's more than 2 standard deviations from the mean, meaning either above or below the mean. So this would be considered a usual observation because it's not more than 2 standard deviations. All right, what's the interquartile range? So to find the IQR, we're starting with an area underneath the curve. By the way, so the inner 50% or the IQR is going to look something along the lines of that. I'll just graph it out for you real quick. To find out what those exact values are, we do second distribution, inverse normal. We're going to do an area of 50%, so 0.5. We're using z-scores. I don't want z-scores. I actually want the actual data. So I'm going to put in the metrics that I have. So centered at 80 with a standard deviation of $20. I'm going to measure the 50% from the center and then hit paste. And those are going to be my left and my right bound here. So from $66.51 to $93.49. So that would be the interquartile range, would be the difference between those two, right? Because those are our first and third quartile. So you can write them down and then subtract the two. No big deal. All right, soda cans, last one. Machine that fills soda fills according to a normal model with a mean of yeah, it's a mean of 12.1 with standard deviation of, this is totally wrong. Okay, let me pause and I will fix this and then we will resume. All right, so the soda machine fills it with a mean of 12.1 and a standard deviation of 0.5. So you can fill in the normal distribution there, just going by 0.5 or 0.05 ounces each time. If the cans claim to have 12 ounces of soda each, what's the percent of cans are underfilled? So underfilled would be anything that was less than 12 ounces. So to find that, we would find the area under the curve. So we're using the CDF. So second normal, CDF, second option. We're going from negative infinity to an upper bound of 12, centered at 12.1 with a standard deviation of 0.05, which would be basically 2 standard deviations, which should be close to 2.5%, so slightly less than that. So 2.3 or 2.28%, however you want to write it, will be considered underfilled. So say management wants to ensure that instead of 2.28 8% or whatever. So instead of 2.3% being underfilled, they want to make sure there's only 1% that's underfilled. So there's two ways they can do that. They can either change the standard deviation or shift the actual mean. So what standard deviation would they have to, so how much more consistent would their machine have to be if they still wanted the setting of 0.5? So to do that, what we need to do is actually calculate the z-score that is associated with the lower 1%. So we need to find out what z-score is going to be the lower 1%, which actually is about right there. So to find that, we're going to do the inverse normal. We're going to start out with an area of 0.01. We're going to measure, we're doing z-score, so it's 0 and 1 because we don't know both the metrics this time. We're measuring from the left, so that will give us negative 2.3, which is this value here, or negative 2.326. Then this is the z-score, which is the observation minus the mean divided by the standard deviation. Now our observation that we're looking for is 12, and our mean is going to be the exact same of 12.1. So it's 12 minus 12.1. Now a trick that we can do here is we can actually switch the order of these two because we're multiplying both sides by the standard deviation and dividing both sides by this value here, our z-score. So now that we've rearranged it, we can put all this in the calculator, which will give us a final answer of, we would need, instead of a standard deviation of 0.05, we would need a standard deviation of 0.043 in order to shrink the total amount of variation so that that 12% is only, or that 12 ounces is only 1% of cans underfilled instead of 2.3% underfilled. The other way of doing this is by instead of changing the standard deviation, we change the mean, which is more practical, right? Because we know how consistent our machine is, and that's what it does. So instead, we would adjust how much it fills it to so that we only have 1%. Even though this is more practical about how we would change it, it's not easier to do with the algebra, but it is just algebra 2, not even algebra 2, because there's no real quadratics here, but it's pretty easy. So what I'm going to do is fill in the standard deviation that I know and the the observation that I want. So I still want 12 ounces, and I'm going to do 0.05, multiply both sides by that value. When we do that, put in the calculator, we get this. Then the only thing I have left to do is subtract 12 from both sides, and then we can divide both sides by a negative if we want. So that would mean that our mean would have to be 12.16. I think that's it. Yes, that's it. My goodness, that was a long practice test. Guys, I am so sorry. I'm exhausted, which means I know you're exhausted, which means I'm probably not going to give you an assignment to do tomorrow because you're doing the practice test. Just make sure you guys are ready for that test on Wednesday, and make sure you're caught up with your homework, and I'll see you guys later. Bye.